Unser erster Keynote-Speaker, Adrian Cockcroft, and now I'm switching into English. I'm really excited to have him on board here as an opener, because I would say he, like a few others of course, but stands for kind of a new thinking in the software world. Of course, from today's perspective, it's some years ago, but he was one of the main architect, as far as I understand, of one of the biggest applications of that time, which was Netflix. And he brought kind of a new thinking into software architecture in terms of scaling, in terms of resilience, in terms of thinking in modularization and microservices, and of course in terms of using the, let's say, at that time, new possibilities provided through the cloud platforms. Having said that, please give a very warm hand to Adrian Cockcroft.
Okay. Thank you. All right. Okay, so it's on. Good. And we have my talk. Right. Thank you. I was trying to think how to approach this particular event, given that it goes back 30 years. And so I have effectively structured this talk as the 30-year history of what I thought was interesting over those 30 years and what I learned over them. And so there's a good chunk in the middle about what we did at Netflix and something at the end about really what I think is interesting right now. But it was a long and twisty road, and there's a picture here I took of Stelvio, which is a very twisty road, if any of you have ever driven up it. So it's 30 years of lessons learned, and for some reason I have a lot of German cars in my history, so I thought you wouldn't mind if I put a few pictures of those up as I went along. Seems appropriate to this audience somehow. So this is what I was doing 30 years ago. I wrote this book while I was at Sun Microsystems, and I was sort of the performance tuning capacity planning expert at Sun Microsystems because I wrote this book. I mean, I figured it all out and wrote some papers, but how many people here 30 years ago were tuning Solaris, hanging around Solaris machines? A small number of you are maybe old enough to remember this. I'm now 65 years old, so I'm properly retired and messing around in my spare time. But I wanted to have a nice picture on the front of something that invoked performance, and I said, well, I got this red Porsche. So that was one of the things I learned was put that thing on the cover, and then everyone says, is that your car? And if that gives you justification to buy one of these cars. And the book was published personally, and I had some royalty checks coming in every quarter, which looked sort of car payment sized for a while. Anyway. So the thing I'm going to teach you about books, it's definitely worth writing a book if you have some expertise and you want to, you can get it onto paper. The act of writing a book causes you to get much deeper into the things you think you know. So if you write it out as a book, you actually know it better. So it helps you learn things better. It also creates that you are the expert, and if it's in an interesting area, then you become the go-to expert. And but the problem with books, and this may not make sense to people, is that they get bigger faster than you can write them. A friend of mine is writing a book on AI. It's a 1,000-page book. It did not start off as a 1,000-page book, but there's it's on AI performance tuning by Chris Fregley, and it will come out in a few months. He's just finished it. And so you say, I can write a 200-page book. That sounds good. I'm going to go do it. You write 50 pages, and then you redo your page plan, and you discover it's now a 300-page book. And then you write, OK, I'm going to keep going. You write another 50 pages, and then you've written 100 pages of a 400-page book. The number of pages left to write is increasing. Right? It's not decreasing. So you have to have a page plan that makes the number of pages you have not written yet go down. This is the biggest thing ever if you try to write a book. Okay, so that's my lessons learned for writing books. So I used the book royalties to pay for a car. And then in 2000, my son was about 10 or 11 at the time. He likes being driven to school in this car. And when he was in his 20s, he bought one of these cars. So now there is one in the family of a 1990 Carrera 4. Anyway, But the other thing that happened was that other people in the company started using this book as a reference, and particularly the distinguished engineers, and I was sort of the go-to person. So how to become a distinguished engineer is to make all the other distinguished engineers come to you as the subject matter expert in something. So that's, if you're trying to get to become a distinguished engineer in a company, make sure all the other distinguished engineers know you and come to you for things. That's the trick. We wrote some other books, and this is one of the things that was learnt during that dot-com boom in the late 90s. It was summarized in this book on capacity planning for internet services. I was doing things like helping some of the very first web properties get up and scale, and just the computers and the operating systems weren't designed for serving HTTP traffic at the time, so we had to do quite a few changes. But we learned a few things: very unpredictable loads, and how to build resilient platforms for global users. This was global web services. It was a new kind of application at the time. Right, so a few years later, it turns out when you're 40, you buy the car you wanted when you were 12. So I ended up with a Citroën SM, which I owned for about 20 years, which is a very interesting, strange car, but it was good for taking to car shows because people would say, I haven't seen one of these before. Anyway. So a little bit later, I was the chief architect for the high-performance computing division of Sun Microsystems. And this is where another sort of lesson learned was I really broadened out my skills. And because I wasn't just the chief architect, our project manager left, so I took on product manager roles, and I was actually figuring out what is the products we're going to release, what is the schedule, what are the features, managing people to delivering that. And then we were setting up partnerships, so I went out and did a lot of business development. I keynoted the supercomputing conference as part of this. And then around that time, I did Six Sigma training, which was a lot of data science, quality engineering. So I really sort of rebuilt my skills. And I was like 40 or so years old, but got a much more breadth. And I was having a great time. But this was at Sun Microsystems, and Sun Microsystems is gradually going out of business at this point and laid off our entire team, unfortunately, in 2004. Like, my boss had to recursively lay off everyone and then lay off himself, and then his boss had to lay off himself. So anyway, so one of the things I learned there was that if companies are growing, there is a culture that works. There is a culture of abundance. Right? There is more money, you're growing, there's more headcount. Like, what are we going to do with the extra headcount we have from our additional revenue? If you stop growing or start shrinking, those companies have a very hard time adjusting. You get to this sort of frozen state where it's extremely hard to get anything done. There's a lot of political infighting comes in. People start hoarding resources. Because when you have abundance, you can kind of, it doesn't matter. There will be more coming later. But when you're in a scarcity position, it's very different. So one of the things I found is that basically you can think of it as growth lubricating culture. It makes it fun to be at a company that's growing. So if you're at a company and it starts shrinking, my advice is get out early. And I didn't get out from Sun early enough, so I learned that lesson. One of my old friends from Sun is joining NVIDIA right now, which is probably the place to be if you want to be in currently the fast-growing company that's got all the money to do everything. All right, so it's about 5 years later, I had this other car, which is a very stripped-down, lightweight, agile thing. But then I was working at eBay, which is, compared to Sun, very fast and agile, and everything was happening quickly. And this car is actually bought from a German dealer to get left-hand drive. So I'm driving around in California with liters and kilometers and things and having to do math in my head to figure out what's going on. So what did I learn at eBay? I was a distinguished engineer in the operations architecture area, and that partly came because when eBay in the late 1990s was growing super fast, they were running on Sun. I was part of the team that went in and helped them get up to speed. So effectively, I joined a customer that knew me that I'd helped out in the past. The thing that really was clear from eBay was this idea of market agility to being the sort of the success thing. How fast could you get new ideas into the marketplace? And then from a technology point of view, this was one of the first places that really did do horizontal scaling with commodity hardware. They were very good at that. They automated things. It's not well known as a case study, because our management didn't want the eBay brand to be a technology brand. So this is a marketplace brand. It's a place you go to buy things. We didn't want to dilute the brand by saying it's also a high technology place. And I think that was a mistake, and it's something that we'll talk about a bit later. But what it means is that people don't realize all the interesting things that happened at eBay. So horizontal scaling on effectively Intel-based cheap hardware from Gateway or Dell or somebody like that. We sharded the databases. This was Sun hardware running Oracle, but we weren't running it as a normal Oracle database. We were effectively running a single table on each one, and we sharded everything out. So it was basically the same kind of NoSQL key value store. It just happened to be built using Oracle. And that means that we had to understand how to do distributed transactions, and we had to denormalize our data stores, because you can't join things that are across multiple machines easily. So that was something that I learned a lot about scaling here. This was a large web property. It ran internationally. The other thing I did at eBay was the research lab, and the thing I really learned was research labs don't work. We had this group off building new technology, and we kept taking it to production and said, oh, that doesn't scale, we're not interested in it, and you guys off in your little ivory tower keep coming up with stupid ideas and whatever. So there was very much an us and them between the research lab and the main engineering team. So that was a bit of a problem. So in 2007, I left. I was at eBay for 2 or 3 years, and I joined Netflix. And what Netflix was doing, and this is a policy that's very powerful, was because they knew they didn't know how to scale. At the time, they had like 20 machines, and they were doing a DVD by mail business that was didn't really have much web presence in terms of high traffic. But they said, we need to learn things. We're going to hire the best people we can find. And 5 miles up the road was eBay. So myself and several other people from eBay joined, and we knew about horizontal scaling. We knew how to build large-scale web services and iterate quickly on them. And one of the reasons I joined was I wanted to learn about personalization. Netflix at that time was known as a place that had figured out some personalization. I wanted to learn all the techniques around how to personalize things. So I did that, and at that time, it was a data center-based Java monolith with weekly releases, sort of a weekly train system, a release cycle, which was very similar to what eBay was doing at the time. So the things I learned at Netflix was how to use personalization algorithms to enhance the user experience. This is something that's much more common now, but that was a very early thing. So if you go back to that period, there was the Netflix Prize, and there were a lot of research into algorithms to do this. The other thing that was very key at Netflix was everything at the company went through A/B testing. It was hypothesis-driven development is the sort of common name for this. Every single thing that went out went through a test. And the new customers that joined were the guinea pigs. Everybody at Netflix gets a different experience because everyone is in a different set of test cells, right? And this is a huge, powerful thing. As you get more and more customers, you can run more tests, and you can run bigger groups of tests, and you can get to a significance in the test much more quickly if you have 10 times as many people in your test cell. So one of the advantages Netflix has as it got bigger was it could actually do more tests more quickly and learn more about its customers than people trying to compete with it that are starting out at a much smaller base. And then the other thing was really everybody at Netflix operated like a research lab. That was the big change. There wasn't a separate research lab. It was really everybody's job to keep up with the latest technology. The other thing about Netflix was the culture. And this book is a good way of looking at that. It's effectively an MBA case study, and most of the times people write a case study about Netflix, they get it completely wrong because they're looking at it from outside and they're not seeing how it worked inside. So it was amazing to be on the inside of this for 7 years. I was at all the quarterly management off-site meetings, seeing all the different parts of the company and all the strategies they were doing. So for me, this was my sort of management strategy training phase of my career. The other thing about the Netflix culture, it was deliberately hard to copy. I'm sorry about that. And there was lots of people that have tried to copy Netflix culture. It's very difficult to do. And that was deliberate. It was seen as a competitive advantage to be doing things that was actually hard for our competitors to copy, but would give us an edge. I tried to explain the way the salary bonus sort of system worked to somebody once, and he just burst out laughing and said, that's impossible. And I tried explaining it to somebody at Amazon and in HR, and their faces went red and they got very upset. Anyway. So in about 2009, we had decided we started to get to the point where we needed to scale, and we had to either go and build big data centers, or we had to figure out a way of not needing to do that. And AWS at that time was just about getting to the point where it seemed plausible. And on a very early version of AWS, I basically did some prototyping. I led a team that prototyped how we were going to do this. And then during 2010, we moved the front end of the system. 2011, we moved the back end. So that was our move to cloud. And this was open source from enterprise software. We had Oracle and Aqualogic, and a bunch of, we'd spent money on enterprise software licenses in the data center. In the cloud, we went to open source as much as we could. So we dramatically reduced our software licensing costs. We also went to a clean new code base. The old code base had got all tangled up. It was all tangled into this Oracle schema. It was a big mess. So we said, no, just write it again. It's actually going to be quicker to write it again and build a new clean base. So, and again, this was, we prototyped it a bit to figure out how to do that. And we also, at the same time, we went from Oracle to Cassandra. We went from a monolith to microservices. So lots of things were changing. Around about this time, my wife was doing well enough that she could buy a car for herself, and she bought a Boxster, which she still has, and it's one of our, it's one of those things, if I had to sell every single car and keep one, this is the one we'd keep. It's just an all-around very nice car. Anyway. So, moving on. Microservices. So people think of this as an architecture, but for me, it's a tactic. The idea we wanted was run what you wrote was the way we were operating. If you're a developer and you have an API that can deploy your software, you use that. So we were using automated delivery, using Jenkins at the time, and later on other systems. But the idea was that we had an automated delivery pipeline. You check code in, it would just flow to production. If it passed the tests, it would go. So your little piece of code would change, but the rest of the system would be untouched. And to do that, we had microservices because we wanted to deploy as individual pieces. So the developers went from writing a jar file and giving it to QA, where they would try and combine all the jar files into a monolith and get it to ship, get it to work so that they could ship it, to taking that same jar file, wrapping it in a service, and delivering that service themselves as often and whenever they felt like doing it. So the point here was that you wanted to minimize coordination across teams. We had, at this time, a few hundred engineers, and a few hundred engineers working on a monolith. We were breaking each other's code too often. That was the fundamental sort of reason why we moved off the monolith. And people say, yes, you can have a well-structured monolith, and you can for a very short period, and it turns into a tangled mess eventually. So that was what we saw. So we went to Cassandra, which at the time was quite a novel thing to do. We were one of the first customers of DataStax, and we pushed this technology. We hired committers in-house. Like when we were looking at these things, we read the source code to said, yeah, this makes sense. We can have we can modify this to do what we want. So we actually contributed to Cassandra. And that's a very different model from buying Oracle, right? But we automated it, and this was set up. One of the reasons we did this, there's the AWS has this availability zone architecture, and we wanted to have a database architecture that worked with that. The other thing about Cassandra is it's extremely scalable. And at various times we did like a 10 times scale. Let's just make sure we have some headroom. Cranked it up. Yep, we did 1 million writes per second, and I did a little blog post on that. Then I started seeing DataStax adverts saying, hey, we can do 1 million writes per second, popping up in my feed, but were basically pointing at the benchmark that I'd published. And then the other thing was chaos engineering. And what is this Chaos Monkey thing about? It was really about getting away from having session state. We wanted our services to be able to just, because we were running on cloud architecture, every now and again an instance would die. We wanted to make sure that we didn't have session state, and we wanted to be store that state somewhere more persistent and replicated. So all state was replicated and persistent. So if any service can be killed at any time, then you should prove that by killing them continuously, and that's what the Chaos Monkey did. It did it during the day, sort of 9 a.m. to 3 p.m., usually like 4 days a week, so that you didn't have Fridays and afternoons, so you didn't have to fix something later on that it found. But the other thing about this is you're trying to auto-scale your system up and down to be very high utilization. You want to be able to scale down very quickly without having to drain traffic out of things. So the point about this is that you can just scale down, and these machines disappear, and the machine that was calling it just retries on another instance and carries on, and it causes very little interruption to it. And then we had Chaos Gorilla, and this is the zone level. So AWS, you have 3 zones. You should be able to run on 2 out of 3 zones. Netflix can. Very few other people can. If you actually try this, normally everything breaks. But what we did was, in the early days, as we were building this architecture, we instituted shutting down zones in production every couple of weeks. So we'd pick a zone at random and shut it down. The script would randomly choose which zone was going to be killed. And we basically, the policies we said was at least 2 instances of each service per zone. So there's always a minimum of 6, 3, 3, 2, 2, 2 across 3 zones. And then the other thing you have to do is zone-aware routing. And if you don't have zone-aware routing, this won't work. Because when your traffic arrives in a zone, you should just be talking to other services in that zone. So you have some load balancer at the top that picks a zone to send this request to. And everything should stay in there except data replication, which pushes the copies to the other zones. It's possible to configure Kubernetes like that, I think, in the last year or so, maybe. But this whole architecture got lost somewhere in translation over the last decade, right? But this is a really crucial way of being zone aware and zone resilient. So in 2011, there were actually some AWS zone outages, and Netflix did just keep running. I have a friend that was working at Reddit Reddit was down, and he was watching shows on Netflix cursing at us. He joined us later on and told us this story. He said, how were you still up when AWS was down? And I've written several presentations along the lines of failing over without falling over. And if you go search for that, there are many. I've given that talk so many times. But it's that is the ultimate thing, right? A lot of you may have a traditional backup data center that you've never failed over to. Right? If that failover exercise is a big fraught thing that maybe you do once a year if you're regulated to the, if you're in a bank or something, they make you do it. We were doing it automatically. We weren't even telling people we were doing the exercise after a while. It just happens and everything just keeps working. And it did sometimes find problems and we'd back out of it, but generally you bake it into the architecture. The other thing in this period was building the technical brand. So everybody knows Netflix is a technology company, right? That's why I'm here today, right? Netflix was not known as a technology company before 2010. It was known a bit for some personalization, but it was not seen as one of the technical brands in the Bay Area. And we actively changed that. That was not an accident, right? It was a PR program we put together. And it was at one of the management offsites, I did a presentation which said, we should consciously build a technology brand around Netflix because of these reasons, right? I'll go to the reasons and why soon. But it was something that I saw that eBay hadn't done, and it caused eBay to miss out on some things. You want to basically be able to, the brand recognition lets you hire better people. It gives you better leverage in several different ways, but that was one of the things we were doing it for. The other reason was that the open source helped condition the market. It caused people to use AWS in similar ways to us, which helped debug AWS for everybody. So there was some pattern spreading involved in this. And then also we were just ended up contributing some projects like Cassandra, and we sort of grew out from that, and we started sharing our own projects. And then we started sharing the whole architecture. And I ran a Netflix open source prize through 2013, where we gave out, we had the winners on stage at re:Invent, and Werner Vogels gave them prizes and things like that. And this is when I started presenting at conferences towards the end of 2010 at QCon in San Francisco was the first presentation. Then I came to QCon London, and I had almost nobody in the audience. Nobody understood what we were doing. And a lot of people at that time said we were crazy. This will never work. You'll be back in your data centers pretty soon. So you might have forgotten that that was the reaction. And it's similar in some ways to the reaction to AI today, right? That stuff it only works for a few crazy people, right? Or maybe it doesn't work at all, right? That was the position that people were giving us. That was the pushback in 2010, 2011. And then finally went, oh, actually, this does seem to work. Maybe we should all figure out how to do it. So this is the value of having a strong technical brand. It helps you hire the best talent in the industry. And the way Netflix approached learning a new thing was, who's the best person in the world at that thing that we could possibly hire? Get them in, give them a budget, do what they tell them, do what they say, right? Netflix can learn, like just recently it's learned how to do live streaming and adverts and content and stuff like that by hiring the best people in the industry to do that, right? So from a corporation point of view, what do corporations know is based on how you hire them. But most people hire people and then sort of actively get them to forget the things that they already know. So it's a very powerful technique to everyone that you hire, what can we learn from you is sort of the culture there. The other thing Netflix was doing was influencing startups to build this aligned technology that built things that we needed. So JFrog, Artifactory, Netflix was basically the first customer for Nginx, Artifactory, Cassandra, and there are probably a few others, though, App Dynamics, a few other things like that. And then you go to those companies, and the power of the Netflix brand is so good if you're a startup that you really, really want it as on your customer list. You want it so badly that you will give us an enormous discount. Like often Netflix would be getting 90% discounts from the vendors it was buying from, right? And the enterprises following along later would pay the full price or maybe get a bit off. But Netflix was getting extremely high discounts because the value of the co-marketing brand is so high. So this feeds back on itself. So this is one of the reasons Netflix is known for having a technical brand. And there's a couple of different ways that this pays for itself. Again, it's a position you can build if you want to. And that I was sort of surfing this brand as one of the faces of Netflix, and so I ended up creating my own brand off of this. And I was talking to so many startups that I got invited to join a venture capital firm. So I went, if anyone ever offers you a chance to join a venture capital firm, just say yes first, and then find out more about it later, because it's very hard to get in. And I was very lucky that I managed to get an opportunity to join one. But I continued telling the story and help startups scaling, being more resilient. And it was all about microservices. Docker containers came out around that time. I was talking about chaos engineering and things like that. But I copied I badged what I was doing as baffling late adopters as a service, because most people couldn't figure out how to consume this. Around this time, the first banks in 2014 were starting to move to cloud. And so what did I learn at the venture capitaling? So this is the 3 different ways that a startup will fail. If you think about, if you're ever trying to pitch an idea, the technology is where you spend most of your time, but that normally just works, right? The technology is actually the least likely thing to fail. So you need to explain what you're doing, but that shouldn't be the emphasis. The problem really is finding a paying market. That's almost always why things fail. I built this thing, I can give it away, but I can't sell it, or nobody wants it, or it just was the wrong thing at the wrong time in the wrong place. And then the third independent way is just what I call execution failure. You hired the wrong people, you spent the wrong money on the wrong things. It's got nothing to do with the technology or the market. You just didn't know how to run a business in the right way to succeed with the funds and the timing and everything that you have to do. So just choices. So if you're trying to pitch, like how does a venture capitalist know that you're going to have good execution choices is really important. Like, who are your advisors? What experience do you have? Why is this the team that will succeed, rather than And then what is the market that you're going after, and why do they have money to spend? And then finally, yeah, this is the technology that solves that problem. So it's kind of backwards from the way most people do that. So talking about a startup that ended up succeeding, I got involved in some very early Tesla stuff, and in 2013 or so, I managed to get hold of a second-hand Tesla Roadster, which I still have. And I still had the Citroen at that time. So very weird, advanced cars for their time. All right, so in 2016, I got the opportunity to join AWS as a VP in marketing. I think this was because most of the content that I'd been producing had ended up flowing through to AWS. Keynoted a bunch of summits. I hired the open source community engagement team, and I did a lot of talks on things like serverless first, the failing over without falling over thing, and speeding up innovation. You can go find those talks if I have time to look at those. But I wanted to talk a bit about open source, because AWS had a terrible reputation for open source, and one of the things I did when I was hired was, can I fix that? And I took the technique I had at Netflix, which is hire the people that know how to do this. I hired people that the open source community trusted and knew and were very senior, and I built a team of people that the community trusted. They just happened to now work for AWS, so they didn't really trust AWS, but they trusted these people, and we figured out how to turn that into trust for the whole organization. The rest of it was just sort of investing in the things we needed to do, joining foundations, having a bit of a budget for it. And then I moved to another role within AWS in 2021, where I was a VP in the sustainability team. And Amazon's the biggest corporate buyer of green energy. I helped write and produce the well-architected guide for sustainability, sort of prescriptive how you should think about sustainability as you're developing systems. And then various other things, including if you ever go to the AWS reInvent conference, there is a sustainability track. And it's so hard to create a new track, and that's sort of the last, but there is one there every year now, and that's sort of a lasting legacy of my team. But what I was really doing was internal alignment, focus, trying to get all of these different people running in all different directions to sort of collaborate and come together and to have one vision of what we were doing. And unfortunately, it's still not a great vision because there's a lot of constraints over what we could talk about publicly, but I did get all that alignment done. And then in 2022, I actually retired from AWS. And one of the things I did was join the Green Software Foundation. I'm leading a project called the Real-Time Cloud Project. It's tracking the sustainability data from the different cloud providers, pulling it in, making sense of it, trying to standardize it, and we're actually writing it up in the form of a standard, which is like, let's say you're trying to deploy into a particular region with a particular vendor. We've got all the data about that, what PUE it is, what the carbon impact of that is, how much green generation that vendor has in that place, all that kind of information. And I ran the green development track at QCon-SF a few years ago. And I've basically built up a whole lot of experience in how carbon accounting works and the different green energy sources, if people want to talk about that. So that was one thing I did when I retired. The other thing I did was I became a technology advisor at Nubank. They have a data science-oriented facility in Berlin. I'm going to go see them this afternoon. It's a customer that I was working with while I was at AWS, and every time I met them, they were N times bigger than the previous year. It's like, there's something going on here. They just grow so fast. Currently over 123 million customers and going global. So they're currently Brazil, Mexico, Colombia, but it will be a much more global company over the next few years. The problem we're trying to solve for there is how to scale up without slowing down. And it's a 12, 13-year-old company, and they still have some of the systems from the early times that are creaking a bit, and we're trying to fix all those. But they aren't just a bank. They also are like a mixture of Expedia, Betfair, eBay, Coinbase, and a telco. You can get your telco service from them in Brazil. So, and all kinds of stuff. So it's like a single app that does everything. And along the way, they started off writing this enclosure and using the Datomic database, and they were buying services from a company called Cognitect, which is where Rich Hickey was, and that's all of the Clojure ecosystem. And then about 5 years ago, they just bought that company. So if you do anything with Clojure, it's actually owned and supported by Nubank. They just bought the entire company, all the intellectual property, and Datomic is an open source, or whatever all they're doing, the Clojure open source project work is all supported by Nubank directly. So it's interesting that they had to basically buy their technology stack. So that brings us up to today pretty well. And earlier this year, I bought a very cool car, which is ludicrously fast, and has but the thing that I really wanted this car for was the active ride. It's amazing. So now every road feels stupidly bumpy unless I'm in this car, and then you get to the track or an autocross, and it just doesn't lean over, and it's amazing stuff. So there's something about here, the intelligent automation of the suspension. I think this is one of the things you'll find in lots more cars coming along. But yeah. This is a car where when you launch it, you tell everybody put your head on the headrest so you don't hurt your neck when you accelerate. It accelerates it over a G. So what have I been doing in terms of sort of playing around more recently? I coded in my early career, but I wasn't really coding seriously over the last few years. But in the last 6 months or last 3 months, I've written a lot of code. But I haven't really written it. I've been using Claude mostly to code it. And what I'm using is a thing called Claude Flow, which is an agent swarm simulator. Some of you may have been playing around with Cursor or Claude Code. That's a single AI engine agent which is sort of thinking for you and trying to write the code. What Claude Flow does is it's a swarm coordinator. So you typically have 5 to 10 agents. Each of them has its own personality, and they're working together. And the outcomes are sort of an order of magnitude better. It works faster, but it also, you're running multiple agents at once, so it burns through your tokens a bit quicker. But the quality of what you get is so much better because you have an agent that is the QA agent. The QA agent runs the tests and complains to the other agents that it doesn't have enough tests and this test failed. That's all it does. It's the only focus it has is making sure that there are good tests and that they pass, right? It doesn't care about anything else. And then there's a coding agent, then maybe there's a UI agent, there's an architect agent that's trying to pick which packages you should be using and researching and things like that. And if there's any other specialization or you're interfacing to something else, there'll be an agent that specializes in that other thing to interface it. And it assembles the agents for you. You don't have to tell it what to do. You just say, build me a thing, send a swarm of agents at it, and it goes and works it out. It's a sort of revelatory thing. Like if you go to use it, it's incredible how little you have to tell it to produce stuff. But you do have to kind of still babysit it, look and get it to build things in short increments because it will overbuild and it will build stuff that's too complicated. So you have to basically tell it to build a plan and build the first step of the plan and then go in and just do a tidy up phase on that plan before you build the next step. So there's a way of working with this. And I am now creating products. I don't need to hire people. I don't need to fund a team. And I'm building quite a lot of stuff. And this is an analogy I have. If you think about the operators we had in 2010, I call them ticket and click it. Right? You send a ticket because you want a machine. And the ticket goes through some like weeks-long approval process. And then somebody gets the ticket and they click buttons on VMware. Right? We went to them and said, great news, we have an AWS API that will give you a machine. Why don't you use that? And he said, no, my job is to do the tickets and click on VMware, right? And VMware didn't have an API then because this was their customer and they didn't want to annoy their customers by automating them out of existence. And so some of those operators went, wow, there's an API. I can go play with this. I know how all this stuff should work. I can go use this API, and I can leverage that. And that was sort of became the sort of initial core of DevOps people. The people that were automating operations came from that mindset. But there were a bunch of people just still pushing back on that for a long time, right? And I think we're still in this situation where you give AI tools to some developers and they're going, it's generating bad code that you shouldn't be really looking at the code. You should be looking at whether it works. Did it build enough tests? Did the tests pass? Right? So there's a way of using this where you're abstracting away from the details and you're just going with it. But some AI developers are kind of going, okay, I see how to use this to do things. But it's a different mindset. So managing an agent swarm, you think like a product manager. I have this, it's like more like behavioral driven development than anything else. These are the behaviors, this is the outcomes I want. And I am going to manage the team as a team lead. Am I like telling them, no, run those tests. No, really run those tests. Sometimes you have to tell it to run the tests multiple times. It says, yeah, I got most of them working. No, I want you to do all of them. And I want better test coverage and whatever. And then you have to go and like, do me a human guide for how to run this myself. And I will just go through and just run, do the install and check everything works myself. And you find a few things there too. But I'm not micromanaging the code it produces. And so what am I building? So I had an idea years ago, and I couldn't get anyone to build it for me, so I started building it myself. And the thought I had was that really consciousness is an observability system. Right? If you think about it, if you're unconscious, consciousness for me is defined by the things that go away when you're unconscious. Right? So I can't ask how you feel or what you want, or have you tell me that you need something, right? But if your computers or your systems can talk to you and you can talk to them, then they're conscious in some sense. So that's what I'm thinking about. How do I make systems conscious? And I started prototyping this on the thing that I currently have around me, which is a house which is too complicated and has too many systems in it, and people can't figure out how to do stuff, right? So what I wanted to do was prototype this by building a knowledge graph of all the different things in my house, everything down to, hey, the internet's not working. Okay, this is what I do when that happens. Or the microwave broke a circuit, flipped a circuit breaker. Well, that circuit breaker is in this closet, and it's this switch, right? That kind of thing. And these are all the apps that control all the IoT devices. So I have to build a knowledge graph, and then I export that as an MCP server so that I can have a thing that you can talk to that understands that knowledge graph about my house. So I'm trying to build that. I built it mostly in Python, and then I built a client library for that in Python, which is the thing I want to put inside my mobile app. But I built it in Python because I wanted to just rapidly develop it and test it. And then the last thing I did before I started traveling and ran out of time was that translate that Python client library to Swift. And it just took 15 minutes, and then it compiled, and then I had run out of time. I haven't actually done much testing on that. But that's kind of you can translate things. It had all the tests already. It had all the protocol. It had I build this thing. I just want it in a different language. Right? If you have some code that's too slow in Python, tell it to make a Rust version, something like that. And I've built myself an iOS app in Swift. I definitely cannot program in Swift. I can't even really read it properly. I can read Python, I've never written it, and this has cost me a few $100s, and I have really done something weeks to months worth of work with this. So that's currently where I am. I did a blog post on this, like vibe coding is so last month. My first agent swarm experience, and that was interesting. Anyway, so that's where we are. So I'm just about to wrap up now. So then, okay, but then there's all these concerns. What about the sustainability impact of AI? How do I think about that? And one of the things is I'm using AI to do something useful to me. Like the sustainability impact of like eating beef or flying internationally is also bad, right? But as long as they do something good for me, I'll I'll deal with that. But one way of thinking about this is that in a few hours of Claude code, I've done what would be definitely person weeks, maybe months of time if it was developed by humans. And the carbon impact of those humans developing it would be vastly more than the hour or so of AI coding. So to some extent, you can say it's a more efficient system. But then we get Jevon's paradox. If it's so easy to generate code, we will just generate vastly more code. So we're going to, I think, have this thing where it's actually effectively more efficient to get a thing done, but we're going to have so much more being done that we're just going to keep overrunning and generating more demand. So I think we're in the middle of that. And I think right now we're in the middle of a transition where this change happened so quickly that the planning systems didn't cope. So right now, like the electricity production plans for country level things take years to plan. And if you suddenly say, no, we've got a much bigger demand that you weren't expecting that's appeared from nowhere, it's going to take a few years to rebuild everything to meet that plan. So we've got people sort of going back to gas and coal and nuclear power, whereas if we were on the previous plan, we were going to be on sustainable power. But I think that's a transitional thing caused by the fact that this wasn't planned in, and we'll get through that. All right, and I wanted to talk a little bit about simplicity. So now right now, it's simple for me to build Swift apps that run in my phone. Right? It didn't used to be, but that's really hiding an enormous amount of complexity. So the point about simplicity is always that you're taking an underlying complex thing and you're putting some patterns over it, you're putting some models over it, some mental models that are scalable, that you can apply in one place and you can scale to different levels, or you can apply them elsewhere, and you're creating abstractions. And the problem with abstractions is that they become leaky, means you need to know how they work. So if you know, I can simply tell it to go build an app for me, but when it doesn't work, I actually have to get in there and find out why it doesn't work. That's a leaky abstraction problem. So as the abstractions get better and more reliable, things just start becoming simpler. And if you just look at things that we think are sort of simple enough that everybody can do them, right? Operating a smartphone. A smartphone is the most ludicrously complicated thing we've ever built, if you look at what's going on and what's behind it. Driving a car. Incredibly complicated thing to be doing safely, right? Driving through a city. It's just, but we sort of assume that just about everybody can figure out how to do these things because we've built patterns, scalable models, and abstractions that work for that. Okay, so that's what I had. Hopefully that was interesting. And I'm going to be here through the morning, and I'm happy to chat to people over lunch or whatever. You can find me, we have a little sort of consulting thing at orionx.net. I'm on Medium, GitHub, Mastodon for social media, and LinkedIn. Most of the discussion about the swarm coding things is happening on LinkedIn. Go follow Reuven Cohen and some of the posts that I've put up there, because there's a really interesting community of discussion going on there. Anyway, that's what I had. Thank you.